Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 1 and our main topic is on the basic differentiation rules. In particular, we are going to look at the product rule of differentiation. So let us state it. Product rule. Remember, so far we have looked at the first three rules, that is power rule. We also looked at the derivative of a constant and derivative of a linear combination. So the fourth one is product rule. Product rule. So what does it state? Is the statement that if y is equals to u of x times v of x, comma, then dy dx will be equal to u prime of x times v of x plus, let me take this to the left, plus u of x times v prime of x. So this is the product rule. So what does it mean? It is applicable when we are differentiating a product of two functions. This is product of u and v, which are functions of x. So the rule is applicable when differentiating a product of two functions. Two functions of the independent variable x. So what does this formula mean? That you keep u constant, it means keep v constant, or simply let's say this, it means you differentiate u while keeping v constant, then plus keep u constant and differentiate v. That is what it means. The first part is you start by differentiating u while keeping v constant, then plus. The other part is keep u constant now, then differentiate v. Add them. The plus here means an addition. Let me write a plus. This is addition. You add them. So that is what we mean by product rule. How do we derive this formula? Before we use it, let us see how to derive that formula. So we will write here derivation. Of course, we are going to derive this from the first principle. So we say let y of x, or I could use f of x, whichever. Let y of x be equal to, let me use f of x. Let me use f of x instead of y of x. So let f of x be equal to u of x times v of x. So from here, it means that f of x plus h will be equal to u of x plus h times v of x plus h. So therefore, I now need the difference. I need f of x plus h minus f of x. That is the same as u of x plus h times v of x plus h. Let me remove this other bracket. It's not necessary. This one is not necessary. Then subtract u of x times v of x. Now, what I'm going to do here is to add and subtract a certain value, a certain function, which we are calling u of x times v of x plus h. So this thing can as well be written as it is equals to u of x plus h times v of x plus h. Now we are adding. Now here we are subtracting, not adding. So you subtract and then you add. So let me start by subtracting. We are subtracting u of x times v of x plus h. We are also adding the same u of x times v of x plus h. Then remember the other term was minus u of x v of x. Look at what I've written in blue color. That's what I've added the same thing and also subtracted. So I've not changed the original form of that function. And so this can as well be written as, I want to combine this to form one group and also this to form another group. So in the first group, what is common? I can see v of x plus h is common. So this can be written as u of x plus h minus u of x, this is in bracket, and v of x plus h is common. Then the other bracket, you can see u of x is common, you can factor that out, so that we have v of x plus h minus v of x. That's what we have. Now, that's our numerator. So we now use the first principle. So you say, using first principle, we now need f prime of x. F prime of x is equals to limit as h approaches 0 of f of x plus h minus f of x, everything over h. And we know the numerator we have found the whole of this, so that's what I'll substitute. So that is limit as h approaches 0 of u of x plus h minus u of x, this one times v of x plus h, then plus u of x into v of x plus h minus v of x. The whole of this should be divided by h. So then apply the properties of limits. You see, with this, you can be able to distribute the limit so that we'll have two terms. The first term is limit as h approaches 0 of u of x plus h minus u of x. This one you multiply by v of x plus h and you divide by h. That should be a straight line. Divide that by h at the first part. The other part is limit as h approaches 0 of, we have u of x times v of x plus h minus v of x. The whole of this is divided by h. You know, again, the properties of evaluating limits, this limit can be written as, this limit can be written as is equals to limit as h approaches 0 of u of x plus h minus u of x. This is divided by h, that one, times limit, times the limit as h approaches 0 of v of x plus h. You see, limit is distributive. So that's why I'm able to distribute it that way. Then plus, here u of x does not depend on h, so if I can factor that out, times the limit as h approaches 0 of v of x plus h minus v of x, everything divided by h. So that one, this can be in bracket. Even this is also in bracket. So now you need to ask yourself, which technique can I use here? The best way is to use direct substitution to evaluate this limit. So when we use direct substitution, look at here, the first bracket. From the definition of derivatives, that's the same as u prime of x. Thus, u prime of x is written as, from the first principle, the limit as h approaches 0 of u of x plus h minus u of x, everything over h. What about here? It is times v of x plus 0, direct substitution. Where there is h, you put 0, plus u of x. What about the other one? It is v prime of x. And so therefore, this can now be written as u prime of x times v of x plus u of x times v prime of x. And so we have shown that when you're given y is equals to u times v, then the derivative dy over dx, or f prime of x, or y prime of x, is the same as u prime times v plus u times v prime. So that completes our proof. This completes our proof. And so you can just take note that when you differentiate this one with respect to x, u times v, you need to get u prime v plus u v prime. That is what we mean by the product rule. Of course, you need to know that u and v here are functions of x, and those primes denote derivatives with respect to x. So this is the product rule. Product rule. Now, I want to give you some examples on how to apply the product rule of differentiation. And in this case, let's look at this example. You write examples. Find dy over dx given that in part A, y is equals to, the simplest one is 1 minus 5 x squared times 6x squared minus 4x plus 1. So you see here we have, sorry, you have a product of two functions. One of them should be u and the other one is v. So let u be this and let the other function be v. So that is part A. So let u be equal to 1 minus 5x squared, and let v be equal to 6x squared minus 4x plus 1. So we need to get u prime. So therefore, or this implies that u prime, now here we are going to use power rule of differentiation. So that will give us negative 10x when you differentiate it. Of what the derivative of 1 is 0, because 1 is a constant term. Then you differentiate negative 5x squared to get negative 10x. And then v prime should give us 12x, use power rule, minus 4. So therefore, come back to the product rule, dy dx is the same as u prime v plus uv prime. So that is equals to our u prime, that is negative 10x. Our v is 6x squared minus 4x plus 1. Then we are adding this to u, which is 1 minus 5x squared, times v prime, which is 12x minus 4. That is our derivative, but it's better that you need to simplify your answer. So when we simplify this, we are going to get, let me open the bracket. We start by multiplying it by negative 10x, so that will give us negative 60x cubed plus 40x squared minus 10x. I'm opening the bracket. The other one will be, when I multiply by 1, we get 12x minus 4. And then when I multiply by negative 5x squared, we get negative 60x cubed plus 20x squared. So that's what we have. And you see now you can simplify. They should now give us, let me use another color, negative 120x cubed. I have combined this and this. Then the x squared, I can see 40 and 20, so that will give us plus 60x squared. Those with x, I can see negative 10 and 12, so that is plus 2x, and then negative 4, the constant term. So that is our derivative in the simplest form. Now let me give you another one where you also have to apply product rule of differentiation. You see what is important here is, are you able to differentiate those two functions, u and v? Because once you know their derivatives, then it is easy to use the formula to find the derivative of y with respect to x. In part B, you are given that y is equals to, the first one is x minus 2, another one is x squared plus 6, another one is x raised to 4, plus 1. You see now here we have a product of three functions of x. So here now we are going to introduce three variables, new variables. Let this be u, let this be v, and let this be w. so that there are 3. So you say let u be equal to x minus 2. This x minus 2. Our v is x squared plus 6, and our w is equals to x raised to 4 plus 1. So let's get the derivatives. What is u prime? Differentiate x, you get 1. Of course, 2 is a constant. When you differentiate, you get 0. What about v prime? That should give us 2x. W prime should give us 4x cubed. So therefore, we now need to find dy dx. Therefore, you see from here, it means y is equals to u times v times w. So to get dy dx, you start by differentiating the first function, keeping the others constant. So we'll have u prime. You differentiate u to get u prime while keeping v and w constant, plus now differentiate the second function, keeping the remaining constant. So u is a constant. We now differentiate v, and also w is constant, plus now differentiate the third function while keeping the first two constants. So u constant, v constant, but now we differentiate. Look at that pattern. Even if you had 4 of them, you start differentiating in steps. First function differentiates, keeping the others constant, plus now differentiate the second, keeping the others constant, plus differentiate the third, keeping the others constant, in that order. And so when we substitute, u prime is 1 times v times w, so that is x squared plus 6 times x raised to 4 plus 1. Now we are now adding to u is x minus 2, v prime we got 2x, w is x raised to 4 plus 1. And lastly, u is x minus 2, v is x squared plus 6, and w prime is 3, not 3, but 4x cubed. That should be 4x cubed. So we can now simplify this. Remember, that's our derivative, but you could also open the bracket. But I don't see the need of having to open the bracket. If you have time, you can open the bracket so that you know that derivative explicitly. Let me multiply the first term, this one. What will it give us? It will give us x raised to 6 plus x squared plus 6x raised to 4 plus 6. That's the first term. What about here? Second term, I can see there is plus, of course, 2x outside into x raised to 5. I'm multiplying by x minus 2. X raised to 5 plus x. Then minus 2x raised to 4 minus 2. Then plus, let's factor out 4x cubed, so that we have x cubed plus 6x, then minus 2x squared minus 12. If I open it completely, I'm going to get x raised to 6 plus x squared plus 6x raised to 4 plus 6 plus 2x raised to 6 plus 2x squared minus 4x raised to 5 minus 4x plus 4x raised to 6 plus 24x raised to 4 minus 8x raised to 5. 12 times 4, that is 48. 48x cubed. And so now we collect the like terms. Let's see, x raised to 6, we have 1. Here we have 2, so that is 3. And another 4, that is 7. So we have 7 times x raised to 6. What about x raised to 5? I can see negative 4, negative 8, that is negative 12. Negative 12 x raised to 5. Any other x raised to 4, we can see the 6 plus 24, that is 30. So that is plus 30 x raised to 4. X cubed, I can see this negative 48 x cubed. X squared, we have 1 plus 2, that is 3. So that is simply 3x squared. What about those with the coefficient of x only? There's negative 4. Only negative 4. Any other coefficient of x only? So where did you get negative 4 from? That was from the second term. So that is negative 4x. And lastly, we have the constant term, that is positive 6. So that's what we have as our derivative of a product of 3 functions of x. 3 functions of x, very important. Now, that is all about production. Thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, to share, and also to like this video. When we meet next, we look at other techniques of differentiation. Bye-bye.